right, we are ready for section 1.3 now, which is where we finally get to learn about the 6 major trigonometric functions. And so we're going to begin with just the xy axis, and we're going to consider an angle, what's called standard position. So standard position is where the initial side of the angle is on the positive x-axis, and then the terminal side is somewhere else. And so here is going to be the angle that I'm going to draw. It's going to be an angle in standard position that passes through some point P. So let's just pick some point P here. Okay, P. The terminal side is going to pass through this point P. So here's our initial side right here, and here is our terminal side right here. And it passes through this point P. This is a very generic point. It has the coordinates x, y. Those are going to be the x, y coordinates for that point. So what we can do is with this, we can draw, from this point, we can draw a vertical down right here. That makes a right angle right here. And the distance from here to here is x, because that's how far left we had to go to get to that point P. And the distance from here to here is y, because the y coordinate is, y is the coordinate for P, for the y coordinate. So this is what we have here. So what we have is an angle of this angle right here, the initial side here, the terminal side here, an angle theta. All right, this is what we have. I'm about to define the 6 trigonometric functions. So using this, if you see this right angle, how far is it to this point P? What is this distance? We can use this triangle that I drew to find that distance using the Pythagorean theorem, which we're allowed to use when we have a right triangle. So, real quick, the Pythagorean theorem is a theorem that relates the lengths of the sides of a right triangle to each other. So, the legs of the triangle are the sides that form the 90-degree angle. And the hypotenuse, which is the longest length, the side across from the 90-degree angle, is, I'm going to call it R in this case. So, or C, I'm sorry, C is what we usually do. So our Pythagorean theorem says that the length of side A squared plus the length of side B squared is equal to the length of side C squared. And so C is equal to the square root of A squared plus B squared. And we can do that with any right triangle that we find. So here's a right triangle that we find, and we say, okay, let's figure out what the length of this is, and I'm going to call this R. I'm going to call this R. So let's figure out what the R is equal to in terms of x and y. Okay, x squared plus y squared is equal to r squared. And so r is equal to the square root of x squared plus y squared. That is what r is equal to. Okay, so we could figure out what r is. Now, we're about to define sine, cosine, tangent. Those are the first 3 trig functions. So we say sine is how you write this, S-I-N-E. But we abbreviate it as S-I-N. And as always, you take the sine of an angle. And it is a ratio. That's what it is. It's a ratio. So the sine of this angle is equal to, this is the definition. I'm just telling you this. You don't necessarily, unless you've had this course before, you don't know what this is. It is a ratio, and it is the ratio of y over r. Y over r, okay? The cosine, which is written like this, the cosine of an angle is abbreviated COS of an angle, and that is equal to x over r. X over r. And then tangent is another trig function. Tangent is abbreviated TAN of an angle, theta, and it is equal to y over x. Y over x. Okay, and then there are, this is the first 3, and the second 3 go like this. There is one called the cosecant, which is abbreviated CSC of theta, and it is defined to be r over y. There is something called the secant, which is abbreviated SEC of theta, and it is defined to be R over X. And then the last one, the sixth one, is called the cotangent. So these are, the cotangent is this, cotangent, which is abbreviated COT of theta. The cotangent of this angle theta is defined to be X over Y. So, in a minute I'm going to show you an easier way to sort of put these in your head, but this is the strict definition of an angle in standard position, how you can find the sine, cosine, tangent, cosecant, secant, and cotangent of this angle. This is the definition right here. And of course, you can't divide by 0, so our denominators can't be 0 for these. Okay, so now there are some relationships that we can talk about with these 6 trig functions: sine, cosine, tangent, cosecant, secant, cotangent. The first one is called reciprocal relationship. So a reciprocal of a number is when you flip-flop the numerator and denominator. If you look at these functions, they're all fractions, right? They have a numerator and denominator. So reciprocal relationships, you can kind of see some, right? The sine of theta is y over r, and the cosecant is r over y. Those are flip-flopped. So here is a relationship we can write. Reciprocal relationships are these. We could say that the sine of theta is equal to 1 over the cosecant of theta. Those are reciprocals of each other. Also, the cosecant of theta is equal to 1 over the sine of theta. Here's another one. We can say that the cosine of theta is 1 over the secant of theta, and the secant of theta is 1 over the cosine of theta. If you look at this, x over r, r over x. Here's one more, tangent, cotangent. We can say that the tangent of theta is 1 over the cotangent of theta, and the cotangent of theta is 1 over the tangent of theta. This is some relationships that relate the trig functions together, reciprocal functions. I find these very helpful because when they ask me to find 6 trig functions, and they will, and they'll ask you to do the same thing, I always find these 3, and then I just remember these are the reciprocal of these, and that makes it real easy. Now, these are only defined, you can only use these when you're not dividing by 0. So, for instance, if the tangent of theta equal to 0, then this one you couldn't use. You'd have to go back to the original function right there to figure out what the cotangent is. So that's just a little qualification we have right there. Okay, now here is the other relationships I want us to know right here, cofunction relationships. So here is another way that these trig functions can relate to each other. If you notice this, there's a little co right here, and then there's a little co right here, and then there's a little co right here. The co-functions, that is another way we can relate these trig functions together. So right here, I have something called co-functions, and then I also have something called complementary relationships. If you remember what a complement angles are, it's 2 angles, x plus y, that add up to be 90 degrees. This is what complementary means. Remember that? So, what can we say about this? This is another way we can relate these guys together. The cofunction identities, they go like this. If we have, let me see where I want to make sure I wrote this down right. Come on, let me find it. Well, basically, it says this, that the sine of some angle theta is equal to its cofunction cosine of its complement, 90 minus theta. 90 minus that is the cofunction of that. And vice versa. So the cosine is equal to the sine of 90 minus theta for that. Okay? Same thing can be said for secant, cosecant. The secant of some angle is equal to its the cosecant of its complement. cosecant of 90 minus theta, and vice versa. The cosecant of theta is equal to the secant of 90 minus theta. And then lastly, the tangent of theta is equal to the cotangent of 90 minus theta, and the cotangent of theta is equal to the tangent of 90 minus theta. Okay, so these are called the complement relationships or the cofunction relationships, because that's how cofunctions relate to each other. Sine, cosine, secant, cosecant, tangent, cotangent. Okay, now I'm going to show you an easier way to remember these trig functions. This is the official definition. Now we're going to see how we can use these just with any right angle. See how this right angle was involved? If we have any right angle involved, we can call out these trig functions. So goes like this, and probably many of you have heard this before. Sohcahtoa, if you've ever heard that phrase before. Here we go. We're about to see that again. I'm going to leave these on the board just so you can see how these go. All right. Let me make a little more room here. All right. Sohcahtoa is a phrase that can help you remember these. So first, I'm going to draw a right triangle. These are, just draw yourself a right triangle. All right. And so label these sides A, B, and C. Let's do that. I kind of want to do it how I have it on your worksheet. So, I labeled these. Yeah, that's okay. And so that means this is typically how we do right triangles. So this is a convention that we'll be using throughout the course. So go ahead and start practicing it now. This side A, across from this side A is this angle A, and so the angles will get capital letters, and the lengths of the sides that are across from them will get lowercase letters. So over here is B, that means that this angle is capital B. Over here is C, that means that this 90-degree angle is capital C. So that is how I will generically label my triangles in whenever I come across one. Okay, so let's call out an angle. Let's call this theta right here. Okay, there's theta. So a minute ago, we learned the official definition of the trig functions, y over r, x over y for the various trig functions. If you have a triangle, you can think of it this way, that the sine of angle theta is equal to the side opposite over the hypotenuse of this. And so what that means is that the sine of this angle theta is opposite B over hypotenuse C. B over C. And the cosine of theta is equal to adjacent, which I'm going to abbreviate like this, adjacent over hypotenuse. Now, adjacent means beside, whatever, something that's adjacent to something is beside it. So we're at angle theta, what side, not the hypotenuse, is beside this angle is A. This is what's adjacent to it. So cosine will be adjacent A over hypotenuse C, A over C. And then the tangent of theta is the opposite side over the adjacent side. The tangent of theta is opposite B over adjacent A is B over A. So what we're learning to do is to define angles for the six trig functions for an angle theta that is between 0 and 90 degrees. The name for this type of angle is an acute angle. And so this has to be an acute angle because it's in a triangle, right? This has got to be less than 90 because 90 is already taken up right there. Okay, so this is how we can define it. Now, Sohcahtoa is a word I've used. This is how you spell it. Sohcahtoa. This is a memory trick. It's a memory device to help remember how to do the trig functions. So what this means is that sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. So this is not so hard to memorize if you know this. So if you can come up with this, and you can, we can come up with the other 6 trig functions using the reciprocal relationships, which I've erased, but they should be on your notes, okay? What is the reciprocal relationship? That cosecant is equal to the reciprocal of sine. So that's going to be hypotenuse over opposite, or in this case, C over B. And that secant is equal to the reciprocal of cosine, which is going to be C over A. And that cotangent is equal to the reciprocal of tangent, or A over B. So once you have these, it's really easy to come up with these. Now, this was for angle theta. What if I name this other angle here? Let's give him another name. Beta is one that they use a lot. That's confusing because I have a B. Let's name it something else. Let's name it something like, I don't know. Here, no, I don't want to, I was going to do gamma. I don't want to do gamma. Let's just do something like X. That's so boring, but there it is. Let's do angle X. That is this angle. I want you to notice something. X also has to be an acute angle. If this is 90 degrees, and it is, that means that these add up to 180. This has got to be less than 90 because this is taking up some of that, okay? So it's another acute angle. So I'll just put it, okay, for some angle X in between 0 and 90 works the same. So in this case, let's go find this. What is the sine? What is the cosine? And what is the tangent of angle X? Well, Sohcahtoa, remember that. Sine is opposite over hypotenuse. So in this case, what is opposite X? Opposite X would be A over C. Just like that. What is cosine is adjacent over hypotenuse. Well, if according to this angle, what is beside this angle? B is the side that's beside that angle, so it's going to be adjacent B over C. And then what is the tangent? Well, tangent is opposite, ready? Opposite over adjacent, so opposite A over adjacent, A over B. Okay, can we come up with the other 3? Yes, we can. Cosecant of X is 1 over the sine, or the reciprocal, C over A. Secant, S-E-C, the secant of X is 1 over the cosine, or C over B. And the cotangent of X is the reciprocal of the tangent, which is going to be B over A. So when we have a triangle, we're going to use a lot of triangles in trig. If you need to talk about the trig functions, knowing this little phrase, Sohcahtoa, it can help you get where you need to go. So I think we are ready to do some practice. So I'm going to stop this video. This was the instruction stuff. Now we're just going to practice some examples using this information we just learned.